Hi. So in the last video, we have talked about exponents. So in this video, we are going to talk about the laws of exponents. So law number 1 says if you have two bases, similar bases multiplying each other, they can be written as a single base. You can take a single base and then sum the powers. As in this case, a power m multiplying a power n can be written as a power m plus n. So here's an example. 3 power 5 multiplying 3 power 7. So what makes this looks like the first, what makes this count as the first law is that the bases are similar. In this case, is 3 is the base, also 3 is the base. So we can use this law. So according to this law, we can write this as 3 power the bases, the sum of the bases, which is 5 plus 7, which is equals to 3 power 5 plus 7, that's 12. So that's the answer. And proof to that is that we can verify it, is that we can write this 3 power 5 as this 3 multiplying 3 multiplying 3 5 times. So this is this. So we can write the multiplication sign like this in between. So times 3 power 7 can be written as 3 power 3 power 3 power 3 power 3 5 times power 3 power 3 7 times. So basically this is the shortened form of the expression and this is the longer form of the expression. So this can be written as 3 power the number of 3's in terms, as in this case 5 times and 7 times. If we add them together, we get 12. So that's how we got the first law. So the second law says if you have similar bases with different or similar powers, you can just write a single base and take the difference of the powers. So as in this case, a power m divided by a power n can be written as a power m minus n. So here's an example. 5 power 8 dividing 5 power 6. The bases are the same? Yes, they are the same. So you can write this as, according to the second rule, 5 power 8 minus 6, which is equal to 5 power 8 minus 6, that's 2. That's 2. So the proof, how we can verify this law is that as in the first case, we can write this 5 power 8 as 5 times 5 times 5 times 5 times 5 times 5. How many times? 6 times 5 times 5. So this division sign can be written as this, and also can be written as this, So we can write it as this division sign. 5 power 6 is nothing but 5 times 5 times 5 times 5 times 5 times 5, 6 times. So in mathematics, if you have similar terms, one at the top dividing that same similar term at the bottom, so they can cancel. So they can cancel into one. So you can cancel this 5 with this with this, this with this, this with this, this with this, this with this. So we are left with only 2 5s. So this can be written as 5 times 5, which is nothing but 5 power 2. So that's how we got the second law. So moving on to the third law, which says if you have a base raised to a power, all raised to another power again, then this is equal to the base raised to the power of the product of the two powers. As in this case, a power m all power n again is equal to a power m times n. So here's an example. 7 power 3 power 2 again It's equals 7 power 3 times 2. The product of the two powers, which is in this case 3 and 2. So the product of 3 and 2 is 6. 3 and 2 is 6. That's how we get 7 power 6. So this is the proof. Basically, 7 power 3 is nothing but 7 times 7 times 7. So this is what is in the bracket. 3 sevens multiplying each other. So this is the bracket, and then this is the power 2. Okay. So this is nothing but 7 times 7 times 7, 3 times, twice, multiplying twice. So this 2 power 2 indicates that whatever is in the bracket is multiplying itself twice. So that's why we get 7 times 7 times 2, 7 times 7 times 7, 3 times, then twice. So this is nothing but just the base, which is 7, repeated similar term, which is 7 here, then raised to the power of the number of times 7 occurred, which is 6 in this case. So that's how we prove the third law. So moving on to the next law, which is fourth law. It says if you have any base power 1, it's just simply the base without the power. So here's an example. 3 power 1 is nothing but just 3 without the power 1. So this is straightforward. I don't think it requires any more explanation. So here's the fifth rule. It says any base raised to power 0 is nothing but 1. So no matter how large or small the base might be, if it's as far as it is raised to a power of 0, then it will turn to 1 automatically. So here's an example with a 4. 4 power 0 is nothing but 1. So as I said before, no matter how large or small the base might be. So in this case, it's a million. A million raised to power 0 is nothing but 1. And here's a proof of how that law came to existence. So 4 power 0 can be written as 4 power 1 divided by 4 power 1. Because according to the second law of the division of exponents, this can be written as 4 power 1 minus 1. Similar bases, then we take the difference of the powers. So in this case, 1 minus 1, which is 4 power 0. So this is equals to this, and this is equals to this. So, and this 4 power 1 divided by 4 power 1 are similar terms. 4 power 1 at the top, 4 power 1 at the bottom. If you can remember, I said similar terms, exactly similar terms at the top and at the bottom of a division will cancel out to 1. So that's how we get this one. So moving on to the sixth law, it says if you have a base power negative raised to power negative value, as in this case a power negative m, it's nothing but 1 over a power positive m. So the sign of the power will change from negative to a positive. So here's an example. 3 power negative 4, according to the sixth rule, can be written as 1 over 3 power positive 4, like this. So here's a proof of how this law came to existence. So basically 1 over 1, the numerator 1, can be written as 3 power 0, because according to the fifth rule, the 17 power 0 is 1. So you can write this as 3 power 0 divided by 3 power 4. So according to the second rule of division of exponents, you can write this as 3 power 0 minus 4. This is nothing but 3 power negative 4. So as you can see, this is equals to this, and this is equals to this. This also is equals to 1 over 3 power 4. So that's how we got that. So that's how we got the sixth rule. So here's the seventh rule, the final rule. It says if you have a power m over n is equals to nth root of a power m. So here's an example. The base 3 power 4 over 5 is nothing but the fifth root of 3 power 4. So that's the seventh rule, and one way to prove it is that 3 power, using this law, 3 power, using this example, excuse me, 3 power 4 over 5 can be written as 3 power 4 dot 1 over 5. So there's a property that says if you have, maybe let me use x power 1 over 3 is nothing but the cube root of x, and x power 1 over 2 is nothing but the square root of x. Can read it as this. So according to this rule, we can rewrite this as 3 power 4 then the fifth root of 3. So here's the proof of how we got to this point.